Hello everyone and welcome back to the channel. Every time you browse a website, use a mobile app or interact with an API, you are using HTTP or its secure cousin, which is HTTPS. It's the invisible language of the web, and it's absolutely fundamental to nearly every system design. In interviews, simply saying data is sent over HTTP isn't enough. Showing a deep understanding of HTTP and HTTPS tells your interviewer you grasp crucial aspects of performance, scalability, and security. Today we are diving into the key HTTP HTTPS concepts you need to ace your next system design interview. So, why HTTP and HTTPS matters in system design? First, request and response foundation. It defines the fundamental way clients and servers communicate with each other, which is the backbone of most web applications and APIs. Number two, performance implications. Different HTTP versions have massive impacts on latency, concurrency, and overall throughput. Understanding these differences allows you to optimize your system. Number three, security core. HTTPS is paramount for protecting user data and ensuring trust. Basically, knowing its mechanism is I guess it's non-negotiable. You need to understand how it works. Number three, scalability enabler. It's stateless. It has a stateless nature, and its stateless nature is key to horizontal scaling, allowing load balancers to distribute requests easily among different servers. Next, we have API design. Like, it dedicates how you design your APIs, whether like RESTful or GraphQL or otherwise, whatever you want. Lastly, it shows depth. It demonstrates you understand the layer of web interactions beyond application logic. Okay, so we talked about why. Next, we'll talk about, this is the most part of this video. We'll talk about the core HTTP concept, which is the language of web, in context of system design interviews. So we talk about three things: the request response model, the statelessness, and the HTTP version and performance evolution. So if we want to talk about the request model, there is first we have four things. We have the HTTP verbs. This is something like, let me get my pen. It will be something like get, post, put, delete, etc. And get to retrieve data, post to create more data, put to edit data, delete to delete data. It's pretty easy. Next, we have headers. And the headers here are key value pairs providing metadata about the request or response, like the content type, the authorization, the user agent, the control cache, things like that. Next, we have the body. The actual data is being sent. That's it. And lastly, we have the status. It's a standardized numerical codes indicating the request outcome. Like, for example, 200 is OK, 404 is not found, 500 is internal server error, and etc. Let me delete all of that. We have what we call statelessness. So HTTP is inherently stateless. Each request from a client to a server is independent. The server doesn't remember past requests. This is a huge advantage for horizontal scaling, as any server can handle any request, but it means you need to explicit mechanism to manage states like user session. So you will use like cookies, which is a small piece of data sent by a server and stored by the client. Maybe you can have like a session ID, like a stored in cookies pointing to a session data stored in shared distributed cache, something like Redis, for example. And lastly, we want to talk about the versions, HTTP versions and performance evolution. This is a key differentiator in your interview, so please focus on this one. We have HTTP 1.1. This introduced persistent connection, like keep alive, allowing multiple requests over a single TCP connection, reducing handshake overhead, but it suffers from head of line blocking, which is one slow response blocks sequence ones. Next, we have HTTP 2. It's a major leap, introduced multiplexing, or basically multiple concurrent requests over a single connection, solving a head of line blocking, header compression, reducing overhead, and server push, sending resources before requested, significantly reduced latency and improved page load times. And lastly, we have HTTP 3, which this is the last evolution built on UDP, which is user datagram protocol instead of TCP. This solves head of line blocking at the connection level, not just the stream level, offers faster connection establishment and better performance and better performance on unreliable networks. It's the future of web transport, in my opinion. Okay. So next we need to talk about the HTTPS, the security imperative. So first, what it is. HTTPS is simply HTTP request transmitted over a secure encrypted connection using a TLS. TLS is the transport layer security, or the procedure SSL. Why this is needed? First, it's for three things. For encryption, like protects data in transit, in transit from eavesdropping. No one can snoop on a sensitive information like passwords or credit card numbers, something like things like that. Number two, for data integrity, ensures that data sends between clients and server hasn't been tampered with during transmission. It's also it's used for authentication, like verifies the identity of the server using digital certificates, preventing man-in-the-middle attacks. How it works, it's you just involves a TLS handshake where clients and servers negotiate encryption keys, exchange certificates, and establish a secure tunnel. Lastly, performance impact. The TLS handshake adds initial latency. Encryption, which is decryption, adds CPU overhead. In the system design, you would discuss SSL termination and load balancers or reverse proxies to offload this work from back-end application servers, improving their performance. Okay. So we will talk right now on HTTP and HTTPS and system design patterns. So first, we will talk about API gateways and microservices communication. All external communication and often internal service-to-service communication happens over HTTP, HTTPS. Number two, load balancers. Layer 7 load balancer inspect HTTP headers to make intelligent routing decision. Number three, caching. HTTP caching headers like cache control, ETAG, and maybe lost modified are fundamental for browser and CDN caching. Number four, WebSockets. While persistent WebSockets start with an HTTP handshake that's upgraded to full duplex communication channel. Lastly, error handling. Proper use of HTTP status code provides clear communication about success, failure, or redirection. Okay. Let's talk about how to talk about HTTP and HTTPS in your system design interviews. First, I would say don't just mention it. Explain why you would choose a specific version or header. Number two, discuss the performance trade-offs. Okay. Number three, always emphasize HTTPS for security for public-facing systems. Number four, connect it to other components, like how HTTP headers enable caching and load balancers interact with HTTP, HTTPS. It shows you understand the interact dance of the web traffic. So yeah, HTTP and HTTPS are more than just a protocol. They are the foundational pillars of modern system design. Mastering these concepts allows you to build not just functional but truly performant, scalable, and secure web applications. Understanding their nuances is a mark of a strong system designer. That's it for this video, and see you in the future.